See here, suppose if you take this problem here, there is a 20 volts voltage source is there. There is a resistor R1 which is equal to 5 ohms. There is a resistor R2 which is equal to 10 ohms. Okay. There is a resistor R3 which is equal to 10 ohms. In this problem, I want to calculate voltage drop across V1, V2, V3 across each and every resistor. What is the V1? Let us take this is 5 ohms. Now I want to calculate what is the V1 and what is the V2 and what is the V3 across each and every resistor. So to calculate voltage drop across each and every resistor, we have to calculate the current I, how much current is flowing in the circuit. How to calculate the current I in this particular circuit here? So we have to assign a clockwise notation I here. Then write the KVL in the circuit. So I already discussed some basics related to how to write the KVL and KCL here. Whenever the current is entering at the negative terminal, take that voltage as the same voltage, minus 20, and this is plus V1, again plus V2, again plus V3, which is equal to 0 by using KVL. By using KVL, you can write this equation here. Okay, but by using the Ohm's law, what is the V1 here? What is the V1? V1 equal to I into R1. Same, V2 equal to I into R2. V3 equal to, because all these are connected in series, the same current is flowing in the circuit, I into R3. So let us substitute minus 20 plus, instead of V1, we know resistance R1. Then what is the value of V1 here? I into, what is the R value here? R1 value 5. Likewise, what is the V2? Here the same current is flowing in the circuit. I into 10 ohms. Plus what is the V3? I into 5, which is equal to 0. So that implies minus 20 plus this is 5i and this is 10i, this is 5i. Total it is 20i, which is equal to 0. From this, 20i equal to 20. So then what is the I value here? 20 by 20, which is equal to 1 ampere. So by using the KVL, we can calculate the current in this a simple loop. All these are connected in series. So it is very, very simple loop. Now, after getting I equal to 1 ampere, so tell me what is the V1 voltage from the Ohm's law? What is the V1 voltage? Sahitya is a 109. And 34.
Yes, sir.
Can you tell me what is the V1 value here?
5, sir.
Voltage drop across resistor R1. So current I equal to 1 ampere, resistor 1 equal to R1 equal to 5. So total 5 volts.
5. 5
Likewise,
V2
I,
is equals to
I
10
into
volts.
this is 10 now. This is 10 volts. And I into
10.
R3. R3 value, yeah, very good.
5.
V1 equal to 5 volts. V2 equal to 10 volts and 5 volts. So these are some small applications related to KVL and Ohms law. So once if you understand this example, then we will do some other problems. So anybody having any doubts in this problem, please respond. So let us take another problem here. Problem number 2. There is a 50 volts source is there. This is 5 ohm resistor is there. This is 10 ohm resistor is there. And this is 20 ohm resistor is there. Plus and minus. So now here the problem is calculate I1, next I2 and I3 in the simple circuit. So all of you note down this problem and try to solve this problem. All of you please note down this problem. So let us see how to solve this problem. Here we are going to use the 3 basic laws. One is Ohm's law, Kirchhoff current law and Kirchhoff voltage. See here, this is a 50 volt source here, and across each and every resistor there is some voltage drop is ever voltage drop will be there. Let us say this is V1 and this is V2 and this is V3. Okay. Now here in this problem we have to calculate I1, what is I1, I2 and I3. Next, what is V1, V2 and V3 values in the following circuit. Now listen, all of you listen carefully how to solve this problem. Yeah. So how many basic loops are there in the circuit? Please, anybody can tell me here. How many loops are there in the circuit? How many loops are there in the circuit? This is one loop, and this is other loop, and this is another outer loop here. So we can write two KVL equations for this loop 1. For this loop 1, this is loop 2, we have to write the two KVL equations. So before writing the KVL equations, and what is the KVL? Algebraic sum of all voltages. So summation of voltages around a closed loop is equal to 0. So, and we have to again write the KCL. Summation of the current at a particular node is equal to 0. So by using the KCL, so at this particular node, how many currents are entering and how many currents are leaving? $19,134. See, if you observe clearly here, this I1 current is entering, this is a node, a principal node. At this particular node, I1 current is entering here, and I3 and I2 currents both are leaving. You write the KCL here. I already discussed. We have to follow some notations. So while as it is a entering current, we have to take I1, and the remaining two currents are leaving currents. So for leaving currents, you have to take minus I2, and this minus I3 is equal to 0. So finally, what can I write here? I1 equal to I2 plus I3. Okay, I1
So
equal to
once
what?
again explain KCL.
Yeah. So we already discussed, all of you listen carefully here. At a particular node, you have to, what is the statement here? Algebraic sum of all voltage, all algebraic sum of the currents which are entering or leaving at a node is equal to 0. So at this node, this I1 current is entering, and I3 and I2 currents are both are leaving currents. Okay, na? I2 and I3 currents are both are leaving currents. We already discussed there is some sign notations. While the current is entering at the particular node, that current should be treated as a positive current. So if you see this at a particular node N, the current is coming towards the node. The current is coming towards the node. Okay, current is coming towards the node. So we are taking that current as a positive current. Now, if you observe these currents, I3 and I2 currents, from this node, these two currents are leaving currents. These two currents are leaving currents. As these two currents are leaving currents, while writing the KCL equation, we have to take negative sign before the I2 and I3, so that this is minus I2, this is minus I3. So algebraic sum of all currents at a particular node which are entering or leaving is equal to 0. But while writing the algebraic sum, you have to consider some notations. Those notations are polarities, sign for that currents based on whether it is a leaving or entering. For particular node, if the current is entering, if the current is entering, if the current is entering, you have to take that current as a positive current. If that current is leaving, you have to take that current as a negative current. Please respond, because at the beginning you should clarify your doubts. Otherwise, for the further classes we will solve some more complex problems. You may feel difficulty at those situations. So try to clarify your doubts now itself. Right? Okay. So this is the equation. I1 equal to I2 plus I3. Okay. Now, so with this equation, so let us say this is equation number 1. With this equation, we have to calculate the voltages V1, V2 and V3 here. Okay, V1, V2 and V3 by writing the KVL. Now, write the KVL in this loop 1. Please, all of you listen carefully. Here I am writing the KVL equations for this loop. So loop 1 means, let us take, this is A, B, C, D, E, F. So for loop A, B, E, F, A, A, B, E, F, A, this is a loop. I am writing by KVL. I am writing the KVL equations. What is the KVL equation? Algebraic sum of all voltages in a loop is equal to 0. So this is 1 volt is source voltage. For this resistor 5 ohms, so V1 drop, voltage drop will be there. That is, you have to give plus and minus here. For this V2 also you have to give plus and minus. So you have to write KVL like this. Now, while writing this KVL here, we have to assign the polarities for V1 and V2. For this resistor, starting you have to give plus and minus. This is plus and minus. So now how many voltages are there in this particular loop? Only this loop. Please tell me. How many voltages
Voltages,
are,
sir.
how many voltages are there in this loop?
2 voltages.
This is 1 voltage source. Voltage drop across this 5 ohm resistor, and this voltage drop across the 10 ohm resistor. This will, you have to consider this one also, because while writing the KVL, we have to consider all the voltages for this loop. So 50 volts one voltage, and voltage across 5 ohm other one is V1, and this is also a voltage voltage 50 volts, and this is V2. And while writing this KVL equation, you have to assign the clockwise direction current. And while writing this KVL algebraic sum, you have to consider the polarities of the each and every voltage here. We have to follow one thumb rule called, if the current is entering at the negative terminal of the particular voltage, you have to treat that voltage as a negative. So we assign the clockwise direction of the current here. So if current is entering at the negative polarity, so we have to take minus 50 volts. Okay, na? Next here also, here where the current is entering, at which polarity is the current is entering here, the voltage means it is a voltage drop across the resistor. Voltage drop across the resistor. At what polarity this current is entering for the V1? Please respond. Is it plus or minus? We have to move clockwise direction. While moving clockwise direction, initially where it is entering? Where it is entering?
Positive, sir.
Positive. So you have to take plus V1. Okay. Next. And again you have to move in this direction. So B2A, there is a branch called 10 ohm resistor. So voltage drop across that 10 ohm resistor is V2. So again it is, as we are moving in clockwise direction, it is entering at plus, right? So I have to write plus V2. How many voltages completed? All voltages are completed, which is equal to 0. So after writing the KVL, then we have to apply the Ohm's law to calculate V1 and V2. So minus 50. Can anybody guess me what is the V1 here? According to Ohm's law, what is the V1 here? What is the V1 according to Ohm's law? V equal to I into R. Okay, na? So I is I1 only. In this branch, how much current is flowing? I1 is current. I1 current is flowing. But what is the value of resistance here? 5 ohms. Pi into I1 plus. What is the V2? Actually, according to Ohm's law, V equal to I into R. But which current is flowing through the 10 ohm resistor? Please respond, Amma. Which current is flowing through the 10 ohm resistor? My question is it I1 current, I3 current, or I2 current?
I2 current, sir.
Yeah. So current is I2, and R value is how much? 10,
10, sir.
which is equal to 0. Okay. So let us say this is equation number 2. Okay, na? Let us say this is equation number 2. Now, Again, you have to write another KVL equation. This.
So why did we took minus 50, sir?
Minus, yeah, that is
Minus
what I,
50.
while writing the KVL, so we assigned the current direction as clockwise direction. Amma. While we are moving in clockwise direction around this loop, all of you listen carefully. Initially, the current is, this battery is having two polarities. This is a voltage source. It is having plus and minus polarities. So as we are moving in this direction, current is entering it initially at a negative polarity. So we have to treat this 50 volts as a negative voltage. Is it clear? Suppose if the battery polarities are like this, plus and minus, then you have to take which polarity? Plus 50. Okay, based on the polarities given in the voltage, for voltage, you have to write that. Now let us take another loop here. Loop. I am taking the loop called B C D E B. B C D E B. So in this loop, there is a 1 voltage V3 plus and minus. Okay. So here also 1 V3 plus and minus. Okay. Now totally how many voltages are there in this loop to write the KVL equation?
2 voltage.
Only in this loop, how many voltage sources are there? Voltage drops are there.
2 voltages.
Yeah, one is V2, another one is V3. So again, in this loop 2, we have to assign the clockwise direction currents. Now, tell me at which polarity of this voltage drop across resistor is this current is entering? At which polarity, Amma?
Minus.
Yeah, minus. So you have to take minus V2 and move in this direction, the same direction. Yeah, we have to move in this direction. V3 is there. At which polarity the current is entering? Which polarity? Plus V3, which is equal to 0. Anybody have any doubts? You can ask here. Now, what is the V2? What is the V2 here? V2 means
10
10 into which current, Amma?
I2.
I2. Next, 20 into which current is flowing? I3 current is flowing, which is equal to 0. Let us say this is equation number 3. So, here, by using the equations 1, 2 and 3, we have to calculate the currents called I1, I2 and I3 currents in the circuit. So let me take this current I1 equal to I2 plus I3. Let me open new one here. Equation 1 is I1 equal to I2 plus I3. This is equation number 1. What is the second equation here? Second equation is minus 50 plus 5I1 plus 10I2. So I am rearranging these terms. 5I1 plus 10I2 equal to plus 50. 5I1 plus 10I2. 5I1 plus 10I2 is equal to 50. That is second equation. What is the third equation?
Minus 10I plus.
Yeah. Minus 10I2 plus 20I3 equal to 0. minus 10 I2 plus 20 I3 equal to 0. So from this we can write 10, this is equation number 3. So let us see from equation number 3, let us take minus 10 I2, and that means 20 I3 equal to 10 I2. So we can write I2 equal to how much, 2 into I3. Okay. Let us substitute, please. This is another equation. And from this equation number 1, let us write I1 equal to I2 plus I3. What is I3 value here? Please respond. I3 value is 1 by 2 into I2. What is the 1 by 2? 0.5. So 1.5 into I2. Just a simplification. From here onwards, you are going to simplify the things. After getting the equations, you know how to solve these equations. So we got, let us say this is equation number 4, and after writing the KVL, KCL and Ohms law, the remaining things are only simplifications. Solving these equations to get the unknown values called I1 and I2. Yeah. Once we get I1 in terms of I2, from equation number 2, from this equation 2, let us substitute I1 value. So 5 into I1. I1 is how much? 1.5 into I2 plus 10 I2 equal to 50. Then simplify, let us simplify this equation amount. So this is how much? 7.5 into I2 plus 10 I2 equal to 50. Then 17.I2 is equal to 17.I2 17.5 I2 equal to 50. Then please tell me I2 value here. 50 by 17.5. The value ఎంత చెప్పండి అమ్మా?
2.85, sir.
Yeah. 2.85.
Yes.
85 amperes. So 2.85 amperes. So we got I2 equal to 2.85 amperes. Once you know I2, what is the I1 value? Let us substitute in this equation. So I1 equal to 1.5 into I2, 2.85. చెప్పండి బాబు, ప్లీజ్.
4.275, sir.
4.275 amperes. Okay. So after getting I1 and I2, what is the I3 value here? I2 equal, so I3 value is how much? I3 equal to 1 by 2 into I2, 2.85. ఎంత వస్తుందమ్మా? 2.85 divided by
1.425, sir.
1.425 amperes. So these are the currents. So these are the currents, I3, I1 and I2 currents. So this is I3 current, This is I2 current, this is I1 currents. So what is the problem here? You have to calculate I1, I2, I3 currents. Okay. Once you get these currents, I1, I2, I3 currents, then you can calculate voltage across each and every resistor. Okay, na? That is the problem. It's all about application of Ohm's law, KVL and KCL. And you can verify this law also. How to verify this? So initially we got I1 current equal to I2 plus I3. So we can verify I1 equal to 4.275, which is sum of I2 and I3 currents. If you add I2 and I3, you will get the I1, which satisfies the KCL equation at a particular node. Okay. Now let us calculate voltage drops across each and every resistor. See, please all of you note down this problem. I will give 2 minutes of time. Note చేసుకుంటున్నారమ్మా. Yeah, let me finish this here. Now, what is the V3 here? How to calculate V3? V3 equal to 20 into I3. V2 equal to 10 into I2. Okay. V1 equal to 5 into I1. So likewise, we can calculate V1, V2, V3 values also. Okay. Please, all of you note down this problem. If you are able to solve this problem on your own, you can easily understand the remaining problem. You can solve the problems on your own also. 5 minutes time ఇస్తానమ్మా, నోట్ చేసుకోండి. Saitija, do you have any doubts in this? 19109. Pujita, 19145. If anybody have any doubts, you can ask them, because this is a very basic problem. Try to understand here. Right? Only application of KCL, KVL and Ohm's law by using the notations. And possible today I will post these recorded classes in Google Classroom. Today evening or tomorrow, by tomorrow morning, I will post all these classes, or the classes which are which are taught earlier. What is current, voltage, power, what is node, loop, next circuit, and Ohm's law, KVL and KCL. Those things I will post in the Google Classroom. All of you join in the Google Classroom. Maximum ఈరోజు ఈవినింగ్ కల్లా పెడతానమ్మా క్లాసెస్. Anybody have any doubts, go through those who didn't attend the classes earlier. All of you go through that recorded classes, and please download those recorded classes and go through it. If anybody have any doubts, you can ask. నోట్ చేసుకున్నారా ఇది? నెక్స్ట్ సెకండ్ పేజ్ కూడా ఓపెన్ చేస్తాను, అది కూడా నోట్ చేసుకోండి. And please tell me what is the V1, V2, V3 voltages here. V1, V2, V3 voltages చెప్తారా నాకు ఇక్కడ?
V1 is equal to 5I1, sir.
ఒక నిమిషం. ఎంత V1 ఈక్వల్ టు మల్టిప్లికేషన్ చేసిన తర్వాత చెప్పండి, మొత్తం వోల్టేజ్ చెప్పండి. 5 into I1, ఓకే. After substituting I1 value, otherwise I will do one thing here. Let me finish this problem. So I1 equal to, please tell me what is I1, I2, I3 values here. 4 point,
I1 is equal to 7.1.
I1 value 4 point, 275. I2 2 point, 85, 1.425, 2.85. One point 425 number.
Yes, sir.
1.425. So after getting these currents, after getting these currents, in the given circuit, so V1, this is V2, and this is V3. Okay, this is 5 ohms, this is 10 ohms. I think this is also 10 ohms, no? 5,
20,
10,
sir.
20. 5, 10, 20. Okay. 5, 10, 20 ohms. So we got this current I1 and this current I2 and this current I3 by using the Ohm's laws. So V1 equal to 5 into 5 into I1, which is equal to 5 into 4.275. Next, V2 equal to 10 into I2, which is equal to 2.85. Next, V3 equal to 20 into I3, which is equal to 1.425. Please tell me these values.
V1 21.375.
21.375. Very good. Next, V2, Amma?
28.5, sir.
28.5. Next, V3?
V3 also same, sir. 28.5.
We can verify the this KVL equation in this problem also. Verify cheyocha? How to verify this V1 and this V2 and this 50? If you add those voltages, the sum should be equal to 0. Okay. So these are the V1, V2, V3 values in the given circuit, and I1, I2, I3 values in the given circuit. Sometimes they will ask calculate the power across this 5 ohm resistor. What is the formula for the power P across 5 ohm resistor? How to calculate the power value in terms of voltage and current? Simply V into I. What is the voltage across this resistor? 21.375 into what is the current here? Current, how much current is flowing? 4.275. So if you do the multiplication, this will be the total power, and units are the watts. Likewise, they may ask any value, power, voltage or current in a particular branch. You can solve those problems by using KCL, KVL and Ohms law.
So power is
Hello?
voltage into current.
Yeah, we already discussed about this power in earlier classes. Simply voltage into current. Power can be calculated voltage into current, but you have to consider a respective voltage and current through particular branch. As I consider this 5 ohm resistor, V1 and I1 are the currents and voltages. And if you want to calculate the power across this one, then you have to consider voltage V2 and current I2. So you have to take respective voltage and respective currents to solve the to calculate the power. Okay. So this is about a application of Ohm's law, KVL and KCL. If any problem is given, this is the procedure to solve the particular problem. If anybody have any doubts, you can ask. And I will share this record classes also. I will give one homework problem. Try to solve that problem. So wait, I will give next problem so that you can wait for 1 minute. Meanwhile, if anybody having any doubts, you can ask them. So please note, all of you note down this problem here. The voltage source plus and minus. So anyway, we can represent this voltage source a circle inside the polarities or longer lane and smaller lane. This is 12 volts, 12 volts. This is 6 ohm, and this is 4 ohm, and this is 2 ohm. This is 3 ohm. All of you note down this problem. This is 12 volt source. All of you note down the circuit. In this, he is asking about, particularly he is asking about calculate voltage V across across the 4 ohm resistor. Calculate voltage V across 4 ohm resistor. And the answer is minus 2.886. I will tell why the minus will come volts. This is the answer. Try to solve this problem at your home. Let us see who will give the answer. So note cheskondam. All of you note down this problem. Completed? Sai Teja, you are not responding, Amma. 19109. Are you there or not? I won't give attendance if you won't respond. Mohan 19126. (108) 19108.
Yes, sir.
Problem note చేసుకున్నారా?
Yes, sir.
Yeah. So I will explain briefly how to solve this problem here. Here we have to calculate voltage across 4 ohm. This is 4 ohm resistor. So this is V. Let me take another color. So that V is here, voltage across 4 ohm resistor, V. But we can assign any value. So this is V, voltage across the 6 ohm, let us say V1 here, minus. And this is V2, and this is V3. Which value you have to calculate here? V2. What is the V2 value? According to these notations. And you have to give these polarities for the resistor, plus and minus. Source they will give the polarities, but for resistor you have to assign the polarities, plus and minus V1. Actually resistor doesn't have the polarities, only the voltage across the resistor have the polarities. According to Ohm's law, there is a voltage drop across the resistor. And for V2 also, plus and minus. So we will discuss very clearly why the plus will be given initially for the resistor later, because it will be treated as a load element. This is also plus and minus. V3, plus and minus. Next, see at this particular node, this is current I1 here. You have to assign the currents, and this is the current. You can take anything, I2, and this is, because always the current is coming from positive polarity of the battery. So I1 ఇలా వస్తున్నాం. I1 is coming from this source, and it is flowing through the resistor. At this particular point, it is divided into I2. Some portion of the current is flowing through the 4 ohms, some portion of the current is flowing through the 2 ohm. I1, I2, I3. Okay. And here one more thing is that as these two are connected in series, same I3 current is flowing through the 2 ohm, as well as I3 current is flowing through the 3 ohm. Same I3 current here also. Please anybody tell me the KCL equation at this node by using KCL. At principal node. This is also node, but as the same current is flowing, we are not considering here. This is principal at node. Please tell me at node 1, What is the KCL equation? How many currents are there? Ranjit, Ranjit, 2106.
sir.
KCL equation చెప్పండి ఇక్కడ.
-12 plus 6 plus
Hello?
-12.
Minus
-12.
KCL ఈక్వేషన్ చెప్పమంటే -12 అంటే ఏంటో బాబు. ఇది 12 కాదు. I2, I3, I subscript 3, I subscript 2, I subscript 1. ఎవరు చెప్తారమ్మా KCL ఈక్వేషన్? (105) 2105. I will close this class within 2 minutes. Please tell me KCL. Tell me the KCL at this node. Hello? మీకు మైక్ ప్రాబ్లం ఉన్నట్టుంది కదా. 134 రెగ్యులర్ 19 134. మా KCL ఈక్వేషన్ చెప్పమ్మా ఇక్కడ.
I1 minus I2 minus I3 minus I4 equals to 0.
I4 ఎక్కడ ఉంది? I1 minus I2 minus I3.
I3 equals to 0.
I3 అంటే సి హియర్ సేమ్ కరెంట్ ఫ్లో అవుతుంది. I3 కరెంట్ అనేది ఇది సేమ్ అంటే రెండు సిరీస్ కాబట్టి సేమ్ కరెంట్ ఫ్లో అవుతుంది. ఓకేనా?
Okay, sir.
సో బట్ వోల్టేజ్ డ్రాప్ V4 వస్తుంది. సో దిస్ ఇస్ V1, V2, V3. ఇది V4 గా తీసుకోండి. టేక్ దిస్ యాజ్ ఏ V. ఓకేనా? which is equal to 0. So likewise, write the KVL for this loop and write the KVL for this loop. You will get the 3 equations. Solve those 3 equations. You will get I2 current. So I2 into 4 ohm will give the VT value, which will be same as this V, voltage across 4 ohm, which will be equal to -2.886. So minus ఎందుకు వస్తుందనేది మీకు తర్వాత చెప్తాను. So this is the way how to solve this problem. So try to solve this homework problem. I will ask the answer in the next class. So start here. Please give our attendance.